Okay, guys, welcome back to the science lab. Today we were going to look, we're sort of doing a little unit on electricity. You guys probably remember we messed with static electricity last week.
We did.
Fun, fun, fun. We're going to try to mess with making a battery today. And we're going to do it, we're actually going to make a lemon battery, and we're going to see if we can't get a lemon battery to power this little LED. And hopefully we'll be able to show you guys. Okay, so batteries, how do they work? Anybody?
Is there a current of electricity that goes through the battery?
You know, you would think that it goes through the battery. That is oftentimes what is thought, but the battery itself is actually it blocks a current of electricity.
Oh.
So we're making lemon batteries, Gesundheit. We're making lemon batteries, so you would think that the lemon itself is like the energy is coming from the lemon, right? But actually that's not the case. It's not a conductor. It actually is going to not conduct things. What it's going to do is actually allow a reaction to take place, and I'm going to show you what that reaction is. So you probably know that a battery has a positive end and a negative end, okay? And those are called the cathode, the positive end, and the anode, the negative end, okay? So what we're going to use is we're going to use galvanized nails. Galvanized means coated in zinc. So galvanized nails, and then copper wire. And just a heads up on the copper wire, it's this was the best copper that I had, but it kind of frays a little bit. So you got to just poke a little hole with the nail first and then stick your piece of copper in, but never fear. So what we'll do is I'm actually going to have you guys each make 2 lemon batteries. You'll stick a zinc nail in one side. You can stick the copper wire in the other side. And we'll essentially have a battery. We'll have a negative end, the anode, and a positive end, the cathode. And the way a battery actually works is the stuff inside, like what's the liquid inside the lemon like?
Acidic.
It's acidic, okay? And there are different types of chemicals that would work well as the inside of a battery. Bases, acids, and salt water works really well. Anything with electrolytes in it. What that electrolyte solution is going to do is it'll react with the zinc, and we'll start pulling zinc molecules away, but they're not, or zinc atoms, I should say, but they're not full atoms. It will be leaving behind electrons on the zinc nail.
Okay.
Those electrons, if given a path, would love to travel to the copper wire that we have. They can't travel through the electrolyte in the lemon. So what they can do is if we give them a wire path, travel through. So I guess what I'll have you guys do first is let's actually make these dang things. So you each need 2 nails. Go ahead and jam them in your lemons. You can be as artistic or not as you want. You each get 2. By the way, there's 2 lemons for each of you.
I need 2 nails.
Oh, sorry.
So one nail per lemon?
You took Becca's nails.
Oh,
I
sorry.
did. I'm,
Okay.
These are my nails.
No,
I
Darren, those are
did.
yours. You're doing fine. Okay, yeah, so 1 nail in
Per
each
lemon.
lemon. Yep.
Okay.
Go ahead, and we got here. Let's go.
Anywhere in the lemon, or
How deep? Like that?
Yeah, just like that. As long as it penetrates the skin and goes
Okay.
into the flesh of the lemon and is getting is able to react with the juice inside the lemon.
Okay.
And we are good. Look at that. Becca's is textbook. Nate's I don't know about, but we'll call Becca's good.
It'll work.
mine's definitely not.
Okay.
Oh wait, both lemons?
Yeah, 1 nail in each lemon.
Okay.
Okay. And the reason that we're doing multiple of these is that 1 lemon battery just ain't gonna cut it. we're gonna try to get a few together. Okay.
Not a lot of power from each one then.
Not a lot of power generated from each one, and we'll talk about that in just a second. What I'm going to try to do is give each of you little strands of wire like this. As I say, you kind of need a starter hole, so you might need to pull that nail out, get a starter hole, and just because it's just not super stiff wire. There's lots of different kind of copper wire that you can buy. This is just something I happen to have for speakers at my house, and it's just wire that will unravel if we let it. So try not to let it. A couple pieces. Let me see. I tried to wrap it up so that it would stay together. Oh no. Becca, there's 2 for you.
So Sam, is this where that old saying comes from? When life gives you lemons?
You make a battery.
Yeah, make a battery.
Exactly
Just
right.
make a battery.
That's exactly right. Yes, I believe it was Pythagoras that once said. Okay, so I'm just trying to keep these wires together here. And again, they seem to unravel, just kind of twist them at the end. Becca, those look perfect. I expected no
Oh,
less.
so we're just putting it in another. We're making another.
Yeah,
hole
we're making
then.
another. So what Becca has here, and you know, we traditionally do
Trying
it
to
just
copy
like Becca
Becca's
has,
now after she's
with them
getting
kind of
so much
sticking
praise.
out. You can do it. You could do them fairly close to each other as long as they weren't touching each other inside.
No, I don't
They
think
just
so.
need they just need distance between them inside of the lemon. Okay. Cool. I think one more for you, Darren.
Thank you.
And Nate, you need one more too. And Becca, you're killing it. Star student. Okay. So since Becca's all done, I'm actually going to have her.
Okay.
So what we have right here is a voltimeter. A voltimeter, you probably hear that word meter at the end. So it's a measuring device that measures voltage. And actually, this can also measure resistance and current. But, okay, so what we're going to do is, do you guys know which is positive, which is negative?
Oh, I know this because my car batteries like it, right?
Positive, negative.
Yeah, red is typically positive and black is typically negative. That's usually how we code it. Now, actually, a voltimeter will work even if you place these on the wrong ends. It'll just give you a negative reading instead of a positive reading, but it's still the reading we want. So, Becca, if you could attach the positive end, the red, to your cathode, the copper, and the other side to your zinc, the anode, and tell us what kind of a reading are you getting there?
It says 0.98.
0.98, and I'll maybe see if I can hold this. Oh, no. 0.98, so we're getting a reading
Oh,
of
0.99.
0.99. So almost a volt, almost a single volt. Okay.
Yeah.
Let's just, why don't we give this over to Darren? Darren, can you just test yours, just for the sake of comparison? Let's just test one more lemon.
Let's take
I
a
bet
look.
mine's better.
Yeah, well, hers are very nice looking.
Do you know how many
We'll
volts
see.
it would take to charge like an iPhone, for example, just for comparison?
Yeah,
or-
so
This
problematically,
one on the copper.
Okay.
we'll get into this in just a second,
Okay.
but we actually are going to be able to make more voltage than like a
No way.
AA battery. What are we
Is it
getting?
better?
Oh,
Nope.
wow.
We getting nothing?
Wait.
Oh, no, we're getting something. We just need to make
Is
sure
it
we make
alive?
contact.
It was
Point,
alive.
oh, there it goes. It went to 0.64. It's kind of bouncing around a little bit.
Yeah, and I think that
I'm
just
not very stable with
I think that it just
Yeah.
has to do with the fact that
hands, I guess.
yep, when as long as it's touching the copper, we're okay. But that's all
Point-
right.
I saw it go up to
0.83.
0.32. Yeah.
Oh.
And 7 for a second.
Yeah, it's jumping around.
And you know, so Nate was sort of asking about whether we could use a lemon to power like our cell phones. Unfortunately, there's this other aspect besides voltage, which is current, and we're not getting a lot of current
Okay.
here. So current is measured in amps, and we're almost certainly getting less than 1 amp of current. So what that means is there's a lot of power, but it's not moving quickly. So we can increase that by connecting some of these guys together, and that's sort of going to be our goal. So let's try this first. What I'll have you guys do is let's have you hook your batteries together, each of you, and then we'll hook each of your battery systems together.
Oh,
in turn.
wow.
Okay. So
I'm going to get shocked.
Yeah.
now, how do you think you connect the batteries together? Becca's already set up
positive
correctly.
to negative.
Yeah, that's exactly right. So I'm just going to have Becca, and we'll have Becca do it first. And Nate, here's yours.
Okay.
But you can watch Becca. She's going to connect her positive cathode on one end or negative anode on one end to the positive cathode
Oh, I see.
on the other end. And what that's done, as Becca can maybe help point out for me here, is she has now the connection, and now she still has a free cathode and a free anode on each side. So it's like she just expanded her batteries. Now this
Battery
is
extension.
this should be, we will be putting batteries in series here, connecting them all together in this way so that they're like one large battery. What that should do is give us a significantly increased voltage. Not sure if it's going to give us the ampage that we need. There's something else we can do to mess with that, but for now we'll keep, so actually, can you hold on one sec, Becca?
Yes.
Okay, so I just want to see what happened. So Becca, could we just test the
test my-
voltage on your lemon battery and see if we got the increase?
hold that
Nate, why don't you
one?
be
Sure.
our display guy there? So Nate's gonna lower,
Oh.
lower. Here we go.
Oh, no, my
can you
hand's
turn
in
it
the
toward
way.
the screen a little bit? Up,
This
Down.
way.
down,
Down.
kind
Nope, by the way.
of. Okay. Okay, so I don't know if you can see, but we were getting 1.86, 1.85.
Oh, wait.
It's probably about doubling it then, right?
Exactly. So in a perfect world, in a perfect system, putting batteries in series should double their power. If you put two 9-volt batteries in series, you should get 18 volts of
Okay.
power.
Okay.
Okay, so just for the heck of it, let's see if Becca's battery is powerful enough to power this LED light. So what I'll do is, oops, sorry.
Oh, no.
What I'll do is connect this LED light here to these leads. Okay, Becca. Now it really doesn't matter, but I think just to try to stick, let's do the red to the cathode, good, to the copper. And we're getting nothing yet.
Nothing.
Lowering the lights in the studio a little bit, but that's really what I expected. Even with that increased voltage, I still think we're not quite there. So Becca, could you take those leads off? We'll use them again in a minute.
We
Okay.
need more lemons.
Yeah, so that is exactly what we need. So we are going to try to do that. So Nate, if you would connect yourself to Becca, And Darren, if you would also connect yourself to Becca, you just have to.
So I'm just going
stand
from
there,
a
I'm sorry.
nail to a copper.
Yeah, so exactly. You want to go from, so Nate is going from the anode to the cathode here, and Darren's going to do the opposite, from the cathode to the anode.
Oh, gotta get a good grip. There we go.
Yeah, don't electrocute yourself.
This is dangerous work.
That's right. So, and I should maybe just say this is totally safe to do at home, again, because even though you're generating a decent amount of voltage, because the current is so low, you really don't have to worry about like electrocuting yourself. So, look at this. We have this like nice little battery now.
It's almost like Christmas lights.
It's like hands
It's
across
all nice.
America.
Oh, we might have some issue there if that's.
Lost a connection.
Okay, so first, let's check
It's just
our
power.
voltmeter here. Nate, can you display again?
Let me see if I can get it in the screen without putting it in front of Becca's face.
Here.
Oh,
Here, let's do it here, maybe.
Yeah, over
No.
a little bit, back towards it, and then twist it this way.
There we
we
go.
go. All right. what are we
Everything's
getting?
backwards.
Look at that.
Whoa.
4.5 volts
Wow.
of power, right? That is a significant amount of voltage. But again, I'm just saying it's going to be low ampage. So let's see. Come on, baby. If we
Okay.
can get some energy coming from here. So again, let's do copper here. And Becca, I'll let you do the last one there. And we'll try to get the lights to come down in the studio just a little bit. Ugh, I think we're not getting. Not.
Is everything?
oh,
This all should be connected just fine here.
There was a moment when I thought I saw it flashing. Okay, there's one other thing that we can try.
Yeah, so we're, just so you know, if you're watching, we are turning down the
sorry.
lights. There's nothing
That
wrong
may
with
be
your
right
TV
in the way. That's exactly right.
to try to get a better view of this light.
Okay, so what I think we should try to do is put the batteries in parallel. Putting them in parallel won't increase voltage, so we'll actually reduce the voltage a little bit, but it should increase ampage, and it might work. So we'll see. So what we need to do in order for this to work is to get two batteries made of 3 lemons each. Can you guys do that for me?
Two
Yes,
batteries,
two
made of
batteries with 3.
lemons
Okay,
each.
so
Let me
let's
take
just.
off the, let me take off the leads from this guy.
So here's 3.
Oh wait, never mind.
And while these guys
We
do
wanna
that, so
disconnect this
previously
then, right?
we had
We'll disconnect
connected
this one.
all of we connected each cathode to the next anode and made this long series of batteries. What we're going to do now is we're going to take 2 batteries that have a free cathode and a free anode, and what we'll do is we'll connect them in what's called in parallel by connecting the 2 free anodes and the 2 free cathodes. So let's spread these out so we can kind of get a good visual. Can we do that one right behind this one actually, Becca?
Yes.
So here's my first lemon battery. We've got, again, free cathode on, free anode on this end, free cathode on this end. And actually, Becca, I need you to flip it for me. Can you flip the battery?
Oh, other way around?
Other way
Yes.
around. I need the other anode on that end.
Oh, okay. Yeah.
So when we put circuits in parallel,
Sorry, I'm twisted here.
it's a slightly different setup where we're going to try to double the current, not the voltage, by connecting. Oh, and you know what? I might be a little low on wires here. Okay.
There's one more here.
Okay, good. Let's see. Can we try to connect right there, Becca?
What, these two?
The 2 anodes. Yep.
Oh.
And I'm going to over here connect these 2 cathodes, and we're going to have a little bit of a fun time connecting this. But before we do that, could we try to get a reading here?
Okay.
Yeah, where are we?
So this is
go, Becca?
Where am I going to do it?
So okay, so
Anywhere?
we'll do it here, and you could do it anywhere. But let's do it here and here.
Oh, wait.
Yep. Nice. Good catch.
Kind of getting it. Turn it
tilt
this way.
tilt it up a little. Yeah. there
All
we go.
right.
Okay, so as you can see, we
No?
dropped by about
All right.
half of our voltage. But what we should have gotten as part of that was an increase in ampage. So we'll see. Now, problematically, I'm 1 alligator clip short. But what I think we should be able to do is get the distance we need from the alligator clip, and I should be able to actually
Okay.
stick the other lead right onto. Unfortunately, those aren't
That
free. I
maybe it
should have just
was.
brought some extras, but okay. So I've got this guy connected over to this lead over here. I'm going to connect this one here, and then I'm just going to have to hold this guy. Well, I guess I can do it with this.
There we go.
Nothing.
It's not working?
Okay, well, I'm super sorry. I tested this yesterday on oranges and potatoes, and I put a bunch of them together and managed to get this really faint glow out of this and I can even prove to you that this guy isn't, that it does in fact work. So I've got just a little hand generator here.
How much does that generate?
Significantly more. Should we test it?
Right. Let's test it.
Oh yeah.
So let's see what happens here.
Let's test it.
And just to be totally transparent with folks at
Your
home,
job.
Try this again.
a lot of this stuff, it can be really finicky. Now there's one more thing we can try. We're probably running short on time here, but Becca, you can actually, well, let me just light it up first.
Oh yeah.
So so it is, we are actually getting, I don't know how well we can actually see that there, but you can see that
That's on the screen.
the LED definitely lights up. So it's definitely functional. Becca, while I'm doing that, can you get a reading for us? Can you do
Do I put it on the clips?
yeah, put it right on the clips.
Oh, wait.
It's okay, yeah. So look at that, we're only getting a reading of 3 volts. And so you must be saying, wait a minute, we were getting 3 volts. We were getting 3 volts with the lemon battery. What the heck's going on? So the truth is, it has to do with current. It's all about current, which we definitely increased, I know, by putting the batteries in parallel, but I'm afraid, so the only other thing we could do, and I think this might just take too much time, but I mentioned earlier in the program that it's not actually the lemons that give us the power, it's the electrons from the zinc. So in theory, what we could do is keep jamming zinc into all these lemons, and it should increase the amount of electrons available, which should increase the current, but it's a little bit finicky, and again, I was able to get this yesterday, but not quite today. So I think I'll actually just wrap it here for today, but if you want to try this at home, please don't be discouraged. Get lots of citrus, try other fruits and veggies, potatoes, oranges, other citrus are great for this. And if you can get a voltimeter, that will give you a sense of really how much voltage you're getting. And from there you can kind of play with trying to get enough voltage to actually get an LED to light up. So anyways, we'll call that a semi-successful, but not quite,
We still got voltage.
experiment. Hey, I mean, we definitely had electricity
voltage.
flowing through. And again, like twice the voltage. So the like amount of power, it was just the rate at which it was flowing was too low.
Makes sense.
So anyways, so we'll wrap it up right there. Thank you so much for joining us here. We'll be back in the Homework Hotline studio in just a minute.